As a marine electrician, while you may not be legally bound by the National Electrical Code, understanding the relationship between ABYC standards and NEC recommendations is important when dealing with shore power cords. Many ABYC standards, including those related to ampacity, are derived from the NEC. Historically, ABYC M-11 specifically addresses AC and DC electrical systems on boats and recommended 6/4 stow OCU cores for 50 amp shore power connections. This recommendation was rooted in the ampacity ratings found in NEC Table 310.15 B16 based on a 75 degrees Celsius rating. It's important to note that the 2023 revision of ABYC M-11 has moved away from specifying ampacity requirements for portable shore power cords, and now it only emphasizes that the cord needs to be appropriately rated for the voltage and amperage it is intended to carry. When considering the use of 8/4 cords, several factors come into play. Firstly, temperature rating of the cable plays a significant role in determining ampacity. A higher temperature rating typically allows for a higher ampacity. ABYC recognizes that shore power cords are often exposed to sunlight, which can increase the cable temperature. Therefore, ABYC recommends using cables with a temperature rating of at least 105 degrees Celsius. Secondly, it's crucial to assess the performance differences between 6/4 and 8/4 cables. The resistance of 8/4 cable is slightly higher than that of 6/4 cable. However, this difference is often negligible and unlikely to significantly impact performance. Thirdly, a considerable gain in portability can be achieved. The 8/4 cable is generally more flexible and easier to handle than the 6/4 cable, making it a more convenient option for portable applications. Finally, it is important to be mindful of potential issues that may arise when offering 8/4 shore power cords. One potential issue is dock outlet compatibility. Some dock outlets may not be compatible with 8/4 cords, and it's imperative to verify compatibility before use. Another factor is marine surveyor requirements. Marine surveyors may expect shore power cords to align with ABYC M-11 standards, so it is important to ensure your cords comply with these standards. In summary, while there isn't a strict legal mandate to adhere to the NEC for portable shore power cords in your context, compliance with ABYC M-11 is still highly recommended for safety and compatibility reasons. Utilizing 8/4 portable shore power cords can provide advantages like increased portability without a significant drop in performance. However, it is crucial to address issues like dock outlet compatibility and ensure that your cords meet the standards expected by marine surveyors. Let's dive a bit deeper into the technical details. Firstly, let's consider the ampacity of conductors. Ampacity refers to the current, measured in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The NEC provides tables that list ampacities for various conductor types and sizes, taking into account factors such as insulation type, ambient temperature, and the number of conductors bundled together. When determining the appropriate conductor size for a particular application, it is important to consult these tables and apply any necessary correction or adjustment factors. Secondly, temperature ratings play a vital role. The temperature rating of a conductor indicates the maximum temperature that the conductor's insulation can withstand without degrading. Conductors with higher temperature ratings can carry more current than conductors with lower temperature ratings, assuming all other factors are equal. It is important to select conductors with temperature ratings that are appropriate for the expected operating conditions. Thirdly, voltage drop is a crucial factor. Voltage drop refers to the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a maximum of 5% for feeders and branch circuits. To minimize voltage drop, it is important to use conductors that are large enough for the intended application. Now let's discuss the ABYC M-11 standard in more detail. This standard covers the installation of electrical systems on boats, including wiring methods, overcurrent protection, and grounding. It is widely recognized as the industry standard for marine electrical safety. ABYC MNIS 11 references the NEC for many of its requirements, but it also includes additional provisions that are specific to the marine environment. For example, ABYC MNIS 11 requires that all wiring be marine grade and that all connections be properly sealed to prevent corrosion. It also includes specific requirements for the installation of shore power systems, including the use of ground fault circuit interrupters, or GFCIs, and shore power cords. Consider the different types of shore power cords. Shore power cords are available in various sizes and configurations depending on the amperage and voltage requirements of the boat. Common shore power cord sizes include 30 amps, 50 amps, and 100 amps, and the voltage can be either 120 volts or 240 volts. Shore power cords must be marine grade and must be equipped with properly sized plugs and connectors. It is important to inspect shore power cords regularly for damage and to replace them if necessary. Let's examine the implications of using 8/4 cords. Using 8/4 cords for 50 amp shore power connections raises several questions. While 8/4 cords may be more flexible and easier to handle, they have a lower ampacity than 6/4 cords. According to NEC Table 310.15 B16, 8 American wire gauge or copper conductors with THHN insulation have an ampacity of 50 amps at 75 degrees Celsius, while 6 AWG copper conductors with THHN insulation have an ampacity of 65 amps at 75 degrees Celsius. However, the ampacity of a conductor can be affected by several factors, including the ambient temperature, the number of conductors bundled together, and the type of insulation. If the 8/4 cords are exposed to high ambient temperatures or are bundled with other conductors, their ampacity may be reduced. The NEC provides correction and adjustment factors that must be applied to the ampacity ratings in Table 310.15 B16 to account for these factors. It is important to consult these factors and apply them correctly to ensure that the conductors are properly sized for the intended application. Now let's examine the practical considerations. In practice, the actual current draw of a boat's electrical system may be less than the rated capacity of the shore power cord. For example, a boat with a 50 amp shore power connection may only draw 30 amps or 40 amps under normal operating conditions. In this case, using 8/4 cords may be acceptable, provided that the conductors are properly sized for the actual current draw and that all applicable correction and adjustment factors are applied. However, it is important to consider the potential for future loads. If the boat's electrical system is upgraded or expanded, the current draw may increase, and the 8/4 cords may no longer be adequate. It is always better to err on the side of caution and use conductors that are large enough for the maximum potential load. Now let's discuss the potential issues. There are several potential issues to be aware of when offering 8/4 portable shore power cords. Firstly, dock outlet compatibility. Some dock outlets may not be compatible with 8/4 cords, especially if the outlets are old or damaged. It is important to verify the compatibility of the dock outlet before using the cord. Secondly, marine surveyor requirements. Marine surveyors may require that portable shore power cords meet ABYC MNIS 11 standards. If the 8/4 cords do not meet these standards, the surveyor may reject them. Thirdly, liability. If you offer 8/4 portable shore power cords to your customers and someone is injured or property is damaged as a result, you could be held liable. It is important to have adequate insurance coverage to protect yourself from liability. Now let's talk about mitigating the risks. To mitigate these risks, it is important to take the following steps. Firstly, consult with a qualified marine electrician. A qualified marine electrician can help you determine the appropriate conductor size for your application and can ensure that all wiring is installed in accordance with applicable codes and standards. Secondly, verify dock outlet compatibility. Before using a portable shore power cord, verify that the dock outlet is compatible with the cord. If you are unsure, consult with a qualified electrician. Thirdly, ensure compliance with ABYC MNIS 11 standards. Make sure that your portable shore power cords meet ABYC MNIS 11 standards. You can obtain a copy of the standard from the ABYC website. Fourthly, obtain adequate insurance coverage. Make sure that you have adequate insurance coverage to protect yourself from liability. The NEC provides guidelines for the selection and installation of electrical equipment and wiring in a variety of applications, including marine environments. While the NEC is not legally binding in all jurisdictions, it is widely recognized as a consensus standard for electrical safety. The ABYC standards are specifically tailored to the marine environment and provide more detailed guidance on many aspects of electrical system design and installation. In general, it is best to follow the more stringent requirements of either the NEC or the ABYC standards, depending on the specific application and the applicable regulations. Let's talk about specific code sections. NEC section 310.15 covers ampacity of conductors. This section provides tables that list the allowable ampacities of various types of conductors based on their size, insulation type, and ambient temperature. The ampacity values in these tables are based on the assumption that the conductors are installed in a raceway or cable tray. If the conductors are installed in free air, their ampacity may be higher. NEC section 400 covers flexible cords and cables. This section specifies the types of flexible cords and cables that are permitted for use in various applications. It also includes requirements for the installation and use of these cords and cables. NEC section 555 covers marinas and boatyards. This section provides additional requirements for the electrical systems in marinas and boatyards, including requirements for shore power receptacles, ground fault protection, and bonding. ABYC M&S 11 provides additional guidance on these topics. ABYC M&S 11 section 11.16 covers shore power systems. This section specifies the requirements for the installation of shore power receptacles, shore power cords, and shore power switches. It also includes requirements for ground fault protection and bonding. ABYC M&S 11 section 11.17 covers wiring methods. This section specifies the types of wiring methods that are permitted for use on boats, including conduit, cable, and flexible cord. It also includes requirements for the installation and support of wiring. When selecting and installing electrical equipment and wiring on a boat, it is important to consider the specific requirements of both the NEC and the ABYC standards. In some cases, the requirements of the two standards may be different. In these cases, it is generally best to follow the more stringent requirements. Let's explore the concept of dirting. Dirting refers to the practice of reducing the ampacity of a conductor to account for factors such as high ambient temperature or the presence of multiple conductors in a raceway. The NEC provides tables that list the dirting factors that must be applied in various situations. For example, if a conductor is installed in an ambient temperature that is higher than 30 degrees Celsius, its ampacity must be reduced by a certain percentage. Similarly, if multiple conductors are installed in a raceway, their ampacity must be reduced to prevent overheating. It is important to apply the appropriate dirting factors to ensure that the conductors are properly sized for the intended application. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electric shock. They work by monitoring the current flowing through a circuit and detecting any imbalance between the hot and neutral conductors. If an imbalance is detected, the GFCI will trip the circuit, cutting off the flow of electricity. GFCIs are required in many locations, including bathrooms, kitchens, and outdoor areas. They are also recommended for use on boats to protect against electric shock hazards. Bonding refers to the practice of connecting all of the metallic parts of a boat's electrical system together to create a common ground. This helps to prevent electric shock hazards and also reduces the risk of corrosion. Bonding is required by both the NEC and the ABYC standards. The bonding system must be properly sized and installed to ensure that it is effective. Finally, let's consider the importance of regular inspections. Regular inspections of a boat's electrical system are essential to ensure that it is operating safely and efficiently. Inspections should be performed by a qualified marine electrician and should include a visual examination of all wiring, connections, and equipment. The electrician should also test the operation of all safety devices such as GFCIs and circuit breakers. Any problems that are found during the inspection should be corrected promptly.